Good afternoon, folks. Thank you very much for showing up for yet another session on containers. Based on the crowd here, I can see there are a lot of questions, so we hope to answer most of your questions. This is Taylor Brown. I'm Matthew John. We are program managers in the operating systems group at Microsoft. We are responsible for Hyper-V and containers. So today we are going to learn more about the what, why, and how. Let's quickly get started. There's a lot of content to cover, but feel free to ask questions probably towards the end once we have gone through a bunch of the material we have to go. So, this was new. So please submit your evaluations. That would be awesome. We would love to know how we can make ourselves better. Quickly moving on. The key things we want to learn today. First step, know what containers are. I would be giving you an incorrect message if I say that you will learn all about containers today, but this will make you be intelligent enough to have a conversation about what containers are, essentially to make you dangerous enough to have that conversation, whether it's through the other developers or to your IT pros, operators, or your managers. We'll also gain insight on when you look at a problem and try to figure out how to solve it, is containers a tool that you will use to solve that problem? And finally, we'll go over what are the main things that Microsoft is doing in this space. And we'll walk you through very quickly all these areas. So starting off with, let me start with a very quick history intro of how this whole thing is and where we are in this inflection points. Way back, people used to deal with physical machines. People still deal with physical machines, but for the most part, developers rarely do it, at least at the cloud or data center level. Then came along machine virtualization that changed how people conceived or looked at data centers, and that brought in a lot of innovation, yet disruption. That also led to this whole concept of infrastructure as a service, or IaaS, and that was the early cloud part. Clicking, maybe not. There. Thank you. That further gave rise to a services-based model where you could have not just infrastructure as a service, but platform as a service and software as a service. That's pretty much where we are today as we are introducing the concept of containers. And throughout the sessions, what you'll learn is that as an operating system construct, containers is not something very new, but there's a bunch of things that go into what containers is and how it is being used in today's environment that makes it fairly interesting, unique, and an inflection point. And that's where it's in the history in terms of something that's new and very important for you to understand where it's falling in. Now, if you are not aware of what containers are, or maybe this is a session, or this is a build conferences where you heard about it for the first time, that's completely okay. It is something that people are discovering, and we'll keep discovering throughout the next few years as people try to wrap their heads around how to use containers in their environments. So, are you clicking? Okay, it worked. So when people talk about containers, there are multiple things when people talk about containers. So let me very quickly give you what they are. So at the very basic concept, a container is an operating system concept that's a runtime. It's a collection of processes that you can aggregate in some form, and you can instantiate it and run it on your machine. You can call that the container runtime. Then you have the container image. Now this is what you use to distribute or deploy your applications, and there's a layering structure in your images. So you have a base image, and then you have an application framework image, and then your application image, and you create these images. And this is where some of the beauty of what containers mean comes into picture, where you can distribute just the layer that you want to distribute, and hence make deployment and iteration of development iteration much faster. And then finally, I guess there's a specific spot I need to look at. There's the whole notion of image repository. How do you get those images that you have just created? And this is a very important part of the whole container ecosystem as well. A container by itself, the runtime by itself, not very interesting. We have solved that problem decades ago. Images, we have many images in the industry. If it's a VM image or an MSI, that's always been there. And distribution mechanism, but when you put all of these together, that's when you start seeing something magical happen, and that's what we are going to talk about. So I'll hand off to Taylor, where he's going to start off with a quick demo, show you guys the basic things, and then start walking you through how to use containers, how containers can be used in a developer's lifecycle.
All right. Thanks, Matthew. So I was thinking about this morning. We've got a couple slides, and we've got some demos. You guys like demos? Demos are better? Better than slides? All right. So here's what we're going to do. We're going to go through the demos, and we're going to go through the slides faster so we get more time for demos. And we're just going to make some demos up as we go along. So let's click over. So I've got a laptop here. It's actually running a build of server, and I've got the UI installed. So those of you who were here for Jeffrey's session last time, you can yell at me later. But I'm actually running it so that I can do this demo. And I've got a virtual machine. Now this virtual machine is going to serve as our container host. It's actually got Docker running inside of it. It's got the Docker engine, the Docker daemon for Windows that we're working on with Docker in the open source community running on it so that we can manage and create our containers. So let's actually interact with that. So I'm going to do this all remotely. So this is the Docker client running on Windows. So I can do something like Docker images. And that will list the images that I have locally pulled in. So right now I've got two. I've got a Windows Server Core one, and I've got one named sysinternals. Now ultimately these will be available in the Docker Hub, and you'll be able to pull them down. So I could decide, hey, the sysinternals one's really cool. I'm going to share it up to the Docker Hub, and other people can pull it down. For now, we'll just start with the ones that we have. So let's actually run a container. So we're going to say Docker run, and I'm going to say --rm, which just says after this container is exited, delete it. I don't ever want to see it again. It's temporary. Just get rid of it. And then I'm going to say -it, which says give me an interactive console with this container. We'll give it the name, and then we'll say what process we want it to run. So I want just the command prompt. So what this is doing is it's actually starting a container. So if we looked over at our Docker daemon, it's doing a bunch of stuff. And there we go. So has anybody ever seen Windows start that fast? No? Well, we've got a full view of Windows. I can do directory listing. I can do all sorts of stuff. But the really cool thing is when we start up a second container. So we're just going to do it again. Docker run, it, boom, cmd. Now we're starting up our second container. And while that guy's starting up, let's go over here and let's do something like delete everything in the C drive. So it's all gone. All right, well, we got our second container up. It's all still there. These are completely individual containers. They have their own view on the file system. And for fun, we'll go ahead and do reg delete hkey lm software. I don't recommend this. Yes. Okay, so let's try like help, no, command, no, We'll just throw that guy away, but everything still works over here, right? They are their own independent view. They've got their own life cycle. They've got their own session. And we'll dive into a little more of that in a moment here. I think it's important to first kind of look a little bit at, we're at a developers conference, about what the actual life cycle, what does this mean for you as a developer? And this is the section we'll get through a little quicker so we can do some more demos, but I think it's important. So, as we think about our life as a developer, we've got our local machine here, we've got nothing on it, this is a new project. The first question we usually have to answer is, what am I going to write this thing in? Right, I've got some project I want to do, what's the language I'm going to use, what's the framework? Is it Node.js, PHP, .NET, whatever that is, right? So we can identify that from a repository like the Docker Hub. And maybe this is actually internal to your company, maybe someone else has established that. But the first thing we do is we pull that in. Now what happens automatically is any dependencies that application framework had get automatically pulled in as well. Now this is important because what it really means is I don't actually have to care about the dependencies that framework had. If it's Node.js and it needed this version of Windows or whatever, Cool, that's great. I don't have to care. It doesn't matter. I just get the framework I need. That's all I have to talk about. And this leads to the part of our job that is the best, right? Writing code. So we use the exact same development environment, the exact same tool set. Now that we've got Visual Studio for Mac, we can use that. That's pretty cool, right? We do everything we just normally would do. We compile our code the same way we would. Or if you're using something like JavaScript, you just, compilation is at the runtime, copy it over. The exact same process. Then we do our next step. This is the new part. We actually create a container image. And we'll look at this in a demo, but Docker has a language for saying this is how we build an image. So we take our compiled code and we put that into the container image. And that container image expresses its dependency. It understands that it needs the application framework. The application framework says, I understand that I need a container OS. And so when we push that back into our central repository and then start talking to, this clicker is just horrible. There we go. Hey. So we start talking to our other developers. Now they can pull that in. We can do unit testing. So I actually think this is one of the coolest things. When you're writing unit tests, how often is it that test 3 passes, but it leaves some state behind, and test 7 then fails? Common? You guys seen that, yeah? Or even worse, because test 3 ran, then test 7 passes. But if test 7 ran independently, oh, we're in trouble. With containers, we can get a clean environment every time, because the container runs exactly the same way every single time, no matter where it runs. As long as the data that's being presented to it is the same, it's going to do the exact same thing. So we get to run our unit test in the same way every time. And we can parallelize it. We can run 10 copies at the same time. We can also share it with our other developers. So the guy down the hall who's writing the front end, yep, you just ship him your container image. He doesn't have to wait for your build to get in and then do a local build and, oh, I accidentally got the wrong version and how do I deploy this? You just give him the container image and he can do his part of the work independently of you. We can also stage it out for integration or QA testing, right? We push it out, then all the device testing and QA happens, and it all happens exactly the same way it happened on your machine, exactly the same way it's going to happen in production. How many people think their job is DevOps? How many would say, yep, I'm DevOps now? Getting more. How many people are pure dev? A lot more. Anybody pure ops? Yeah, 1 or 2. So we talked about the developer part, and we talked about pushing to the repository. The ops side of this, is that we figure out how to deploy this into a cloud. Right? So we write all the scripts, we write all the things that push this into whatever cloud it is, Azure or AWS. Honestly, I don't care. We work on the container side of it. Love you to use Azure, but if that's what you're using, that's where we're at. Or your local cloud. Then we actually figure out how to get some analytics, right? We do some communication. Maybe we're listening to our customers, we get a bug file, something happens that causes us need to make a change. We just change the container image, push to the repository, and it gets pushed out to the cloud. And it runs the exact same way. Now what happens if during that we had a bug? Something broke. So today we get a phone call 3 o'clock that says, hey, the live site's down, we got to figure out how to roll it back. Can we just uninstall your fix? Do we have to redeploy everything? With containers, we just roll back to the previous version of the container. It still lives in the repository. It's immutable. We can just simply say, nope, run the other version, and it'll run the exact same way it did yesterday before the fix went in. And so then when we come in the next day, we can actually fix the bug and do a redeployment. Right? And this is real. So let's look back over here. So one of the coolest features of Windows 10, multi-desktop, you can switch between. So I've got my code here, and I've written a really cool app, right? All it does is does a console write line, but it's pretty cool. And if I build this, it builds fine, and I can kick over to command window, and I can run bin debug demo app, and sure enough, it says it's a pretty cool app. Now, how do I get that into a container? So we talked a little bit a minute ago about this way to build containers. That's called a Docker file. Give it a make file for a container. And so it's got some instructions. They're pretty straightforward. It says from Windows Server Core. So that's the image that we're going to start from. That's our starting point. Now, if I was using an application framework like Node.js or something, I would say from Node.js. And what that tells Docker is, hey, make sure that this image is there. This is the one we're going to start from. If it's not there, pull it in, bring it in. Next thing we're going to do is set the working directory. So all that's doing is saying, don't start me in C Windows System 32, just start me in C:. And then we're going to copy in all of the compiled binaries, and we're going to set the default command to run to be my demo app command. So this is the default. When you just do a run, that's what it's going to do. All right, so we're going to say docker build -t demo app version 1. So here it goes. It's doing a build. So it's saying from Windows Server Core, there's our working directory. It's copying over our code and setting that command. And so now if we do a Docker images, we're going to see this new image there, demo app, right? You all with me so far? Yep. Let's run this guy. So we say docker run rm it demo app. Oop. Version 1. So here we go. We're starting our container, and we're going to start our demo app inside of it. And since I didn't say interactive, or since I didn't specify a command, it's just going to run and output that app. So everything works. That's pretty cool. But my app has, needs something a little more special. So I'm going to add some code to it. Now, if you were paying attention during the keynote, when we actually ran the first container demo, you saw that there was a step in there of copying this MSV CR120 DLL. This is actually a real example. So the whole demo app that we built for the keynote had a dependency on that DLL. Guess what? It's installed by Visual Studio. So everywhere it was just working fine because we had Visual Studio everywhere the web app was running. The first time we tried to deploy it into a container, everybody freaked out. Oh, no, the container's broken, nothing works. Well, no, they just didn't have that DLL in there, right? So this is exactly an example of it works on my machine, goes to production, it doesn't work anymore. That's what we had to do to fix the keynote demo, was copy that in. So we're recreating that here. So I build this guy, builds fine, go back over. So if we do our bin debug demo app, it works here. Now if we do a docker build, -t demo app 2, oops. There we go, so we're rebuilding now. Now if I actually had more steps in here, it would only actually do the parts that had changed, which is really cool. So there we're done. We do our Docker images again. So now we've got demo app 2 and demo app 1. So let's do docker run rm demo app 2. So now we're running our 2.0. What do you think is going to happen? Boom! Right, everything blew up. But the power of containers, I can just go back and run version 1. Right? And I can go fix that. I can go find what dependency it was needed and go put that in. Right? Cool stuff? Yeah? So let's look at Mark's long-lost demo from yesterday. All right, so we got a clean image here. So this was the demo that Mark wanted to do during his second session, but just ran out of time. So we've got the sysinternals image here. And so what I'm actually going to do, since I didn't build this here, we're going to say docker history. And what this is showing us is the history of that image. So the first thing it did is it set the maintainer as me, and then it set the working directory. And then it copied some stuff over. That actually happens to be all of the sysinternals tools, like all of the Process Explorer and Object Monitor and all that stuff. And then it set the admin password to password, because I'm super secure. I've got a symbol in there, so, and a number. That's good. And then I'm setting the command to run to be cmd and then ipconfig, so I can see the IP address of the container. Every container can get its own IP address. You can also use natting, but it can have its own IP, its own MAC address, everything. So let's go ahead and run this guy. So we'll say docker run rmit sysinternals. While that guy spawns up, I'm going to open another window here. All right, so there we go. We've got our container up and running. And it's got an IP address, 192.168.0.18. And I can draw into it. And I can go into the sysinternal suite. Now, if I try to run something like Process Explorer, doesn't get much, right? That's a UI-based tool. It has a GUI associated with it. For those of you who were around for Jeffrey's session, you know that GUIs are like heroin. They're fun the first time, but then they just get worse and worse. But you know what? We kind of need our GUI right now. So first off, I forgot the IP address, but let's actually show connecting into this container. So for those of you who don't know, you can actually TS into a container. I wrote a little tool to help me with this. It's just a wraparound RDP, but I can actually terminal serve into a container. And I'll prove it. I'm in a container. This is the container. So if I do a dir, same stuff, right? If I make a new file in here, so let's say echo foo to hi:/hi.text. Go over here, dir. There's my hi.text, right? Why would I ever want to do this though? Well, because I've got a tool like sysinternals that I want to run for some reason I need to do it. Maybe it has a EULA that I have to accept. Boom, I'm in a container, I'm running sysinternals, I'm TS'd in. Now, this isn't what we're going to do every day, but as we're building images, this is actually a very handy technique, and it's part of the reason we did it. So what do we see inside the container? Well, we see that we've got a system process, we see that we've got services, we've got our service host, we've got all these things. It's pretty cool. What we don't notice is that there's actually two copies of services running. There's the ones in the container, there's the ones on the container host. If I had 3 containers running, there'd be 3 copies of the services, there'd be 1 on the host. They each have their own view. They have their own set of services, they have their own world. They're completely contained. Now they're sharing the kernel, so kernel components are shared. So we get all the density sharing around that, but their user mode, the things that matter for most of our applications, are completely independent from each other. Cool stuff? You guys excited? Yeah? So if we have time at the end, we'll do even more, but kick back over to Matthew.
All right, thanks, Taylor. That was really cool. That's the thing that excites me the most about the things we can do with it. So very quickly, let me try to summarize all the cool attributes of containers that you have seen so far. There's definitely more. Yes, maybe I should stand here. So one thing that you just saw was the fast iteration, the way with which you can speed your development cycle. It's very easy to create these images. It's very easy to deploy and test it as a developer. So that life cycle is very rapid. So that's one. What we did not see, but is a core aspect of a container runtime, is resource control. You can control the resources, be it CPU, be it memory, be it storage, or networking, and you can control it from how much you want to reserve or how much you want to limit it from using. So that's the other big thing that you can start using it. Deployment. A rapid deployment model is something that the operations guy is concerned about. Be it bug fixes that's being rolled out or rolling back, be it new versions of an application that can be run side by side. Throughout the whole build session, you saw how the services architecture allows for these things to happen. And so containers have that attribute which says that I can use the existing base images and the runtime, the platform images, and just modify your app layer and keep deploying it again and again and over, and the time to deploy is much faster. Earlier, you saw the demo during Nano Server where he was talking about how small the Nano Server image is. But even that is waste if you have to redeploy it every time you have to ship an application that runs on Nano Server. So if your Node.js script is 15 lines of code, redeploying that should not take 50 meg. So that's the whole thing about rapid deployment. Now this is one of those key attributes of containers. Maybe it's the key attribute of how you define your next generation of application, which is state separated. Taylor demonstrated it. I don't know if the nuance was clear for everyone, but the typical use case of a container is you create an image, you run it, whatever gets written to its local environment or the scratch space, you pretty much discard it unless you are in the process of creating another image. But most of the time at runtime, it's supposed to be discarded. So essentially what you're really building, your application or microservice that you're building, is state separated. Either it's stateless, that it doesn't have any state and it's just performing tasks, or you're offering its state as part of your startup. So in either case, the state is separate. If you really want to persist information, you provide that information or that the store for it to persist the information. That might be on a network store, that might be a local file, a local volume that you are passing in to the runtime of the container. But the container itself, the code that you have written, should always assume that it's state separated. So that's kind of something new. And the final thing is the immutability. This was again demonstrated when Taylor showed how you can start the same container image over and over and over again, and you're guaranteed to start from the same state. And that's a very important aspect of ensuring that you as a developer, when you have developed something and you have tested it in a container environment and you provide that environment or the image to your production environment, it's guaranteed that nothing has changed from a binary point of view, from the bits point of view, from the state that's in it. Now, of course, there are aspects of it that still changes. You can still call it state. For example, you might be running in a test environment with a test network. In production, that might be a different network. So the immutability is in the code, is in the state that's confined inside the bits of your container image, but not necessarily completely in the environment. So that's something to keep in mind, though. So these are some of the attributes that containers offer. So what are the applications that you can think of? What does that suit them for? And, oops. And, okay. I can say that it's pretty much everything that you can think of. Any new kind of problems that you are thinking of, any kind of software that you're thinking of writing, you should start thinking about why is a container-based environment, a microservices-based environment, not the right model. So you might be building out a distributed computing application where it's just spread out. Container makes sense. If you're building out a database, depending on the kind of database you have created, or if it's a proprietary database or a third-party database, you should think about, is the state of the database part, is that separatable from the runtime? Can I provide that as a file to my runtime and just instantiate the bits as it comes and goes? Great environment for web, if it's static or as a service, a web worker role. A perfect opportunity is the scale-out kind of an application where you are literally providing the state as you're scaling out the application or scaling it back in. You just launch as many containers as you want, and at the runtime, you're saying how many instances you want for whatever kind of resources that you're trying to maximize to. And finally, different kinds of tasks. It could be background tasks, report generation, a print task. Any of those things that you feel can be run in the background are all great application or use cases for containers. Now, having said that, if you have existing applications that you want to containerize, these are some of the questions you need to start thinking of, saying, how much of that application is expecting the state to be written back? Now, one of the interesting things about containers is also the life cycle of how you manage the containers. A traditional virtual machine or a physical machine, you are managing the whole environment. You have your application, the application framework, the operating system, and you're managing and patching and making sure that the system lives on. So you go through the reboot cycle, the patch cycle, and everything else just to support that one application. In the case of containers, in the case of container deployments, you don't think about those things. They are two distinct scenarios. You get your new base image, you get your new application framework, you rebuild your package, as Taylor showed, it's a Docker build, and you're building a new image, and the new image gets deployed, probably alongside with the old image. So that's until now, what we talked about is all generic container stuff. Most of what we talked about is applicable to Linux world as it's to Windows world. Now let me switch gears a bit and talk about what's Microsoft doing and how is Microsoft bringing its own signature to the whole container space. So the first thing is we actually have two runtime environments. Some of you heard Jeffrey and Andrew talk about the NanoServer environment. So we have NanoServer both as a container host on which you can run containers and as a runtime. NanoServer, okay, we're fine. So Nano Server provides a reduced API set, but a much more tighter set of APIs, a much more tighter runtime environment. And we all love to use the term born in the cloud applications. Nano Server becomes the perfect environment for you to write your next born in the cloud application. You should be really thinking, if you don't believe that Nano Server is the right environment, then why not? And then we have server code. This is a traditional application, a traditional runtime where you have higher compared with your existing application. So if you find that you have existing applications that use the full API set that is provided in server core, and you do not want to refactor your application, then we have server core as a runtime as well. So both those runtimes are supported in our container model. So that's one. Then we have the container runtime itself. Until now, we just talked about the Windows Server container. So all the demo that you saw is all about the Windows Server container. The Windows Server container shares the kernel. The container runtime has the common kernel with the container host itself. This is very similar to pretty much exactly the same as the Linux environment, where the Linux containers, the Docker created containers, they share the same kernel. Now, it has a lot of attributes in terms of increased density, you get more mobility, all the attributes we just talked about. It's as secure as the operating system. I know there's a lot of emphasis that we put in to Windows and to the Linux environment to ensure that no security vulnerability is left open, but it's there. So that's our story in terms of this is Linux containers, and we have our own Windows Server containers. But when we started down this journey of Windows Server containers, that when we said shared kernel and everything else, we immediately got feedback, and we had our own internal deployments with Azure and our own services where we felt this is not enough. Some element of tighter isolation or harder isolation is needed. And that was very clearly called out, both internally and as we started exploring with our larger enterprise customers. They said, yeah, great, containers are great, awesome from a dev test point of view, but in terms of a production deployment, I need more. I need more isolation. So, well, help me define what is this more isolation. I like the VM-based isolation, where I know that part of the model of a virtual machine is that even if the virtual machine is running completely hostile code, we are guaranteeing that that hostile code can never leak into the host or attack the other virtual machines. And people are used to that, and they wanted that. And they call that's the level of isolation I want. I want guarantees. I want to make sure that this environment cannot affect any other runtime. And we said, okay. Well, so that's when we said, interestingly, Microsoft has virtualization technologies, and it's a proven technology. As I said, let's marry the two. Let's build Hyper-V container. And all we are doing with that Hyper-V container is we took the Windows Server container and wrapped it around with a virtualization extension, a hardware-based virtualization extension, to ensure that nothing can leak out. So essentially what we have done here is we are not sharing the kernel. So the container host kernel is not the same as the kernel that's running inside the Hyper-V container. Now, that's a very powerful statement. What I've just described is that nothing changed in terms of your experience. Nothing changed in terms of the image that I had created. Nothing changed in my development lifecycle of how I create container images. It's just at runtime, I can flip a switch, or the operations person can flip a switch based on the policies of the company and say, I want to run that image as a server container, Windows Server container, or I want to run it as a Hyper-V container. I get comparable benefits in terms of density, in terms of startup time, and all the other attributes that I have. Again, my workflow did not change at all. There was just one flag that changed saying, please make it more isolated. So that's essentially what we have done. Now, we are not at a point where we can demo Hyper-V containers today, But that's something we are actively working on pretty soon, later this year. We want to start showcasing that. And the demo will be pretty uninteresting. It won't look any different than whatever Taylor has been talking about. So it will be pretty boring.
That's my job, to be boring. Make a demo.
So where would you use Hyper-V containers? And a couple of scenarios that we have called out is this whole environment of multi-tenancy. So if I have some code that's I want to host in a container that's not written by you, then you prefer to put a tighter isolation boundary. And typically, multi-tenant environments becomes top of the priority. That's a perfect use case where you can use that. There are other compliancy use cases where even if you're not running third-party code, but you have a port exposed, and you're afraid that someone might sneak in through that port using buffer overflow or whatever else it is, and try to get into your container and through your container attack your container host. Well, if you are paranoid, that's another use case for the Hyper-V container. So this is where we start talking about the level of options that you get with whatever we are building. So we have the different container runtimes. It uses exactly the same image, and the same image can be, you could have created that image using Hyper-V containers to build, or you could have created it using Windows Server containers to build. And at runtime, you can choose to run it as a Windows Server container or a Hyper-V container. And the coolest thing is, you could have done you could build the experience completely using a Docker API, a Docker management head, using the Docker Hub, essentially creating Dockerized containers, even though underneath the covers it's all Windows Server container or the Hyper-V container. So that's one experience, and that's the experience most people are used to and comfortable with. But at the same time, there are a lot of folks who ask us about, are you going to build a PowerShell experience? Because that's what we are familiar with. And yes, absolutely. We will provide that experience as well. And in fact, the architecture that we have built allows for a next generation of whoever else wants to come up with and say, I have a new experience for managing containers. Hey, Microsoft, I want to play and party on with that as well. And I said, sure. Just add on and provide that experience, and if it takes off, awesome. Because that's what we really want to enable. And I don't know if you guys have internalized the theme, that's the transformation that Microsoft is going through, which enables this kind of come build your experience and we will take you along. Essentially, we are getting to that level of choice for our developers, for our IT pros, for our customers to say, we don't want to tell you it's the Microsoft stack or nothing. Essentially, we are trying to embrace whatever is out there, whatever makes you feel the most comfortable with, be it development platforms, be it runtime environments, be it management API set, whatever it is. So that's one of the things about the modern development platform. Moving on to where do I use containers? And this is one of the questions that keep coming up. There's always this question about, so is containers running on physical, on VMs? What can I do with it? So very quickly, let me walk you through where containers can be deployed. So obviously, there's a physical machine, and you can have virtual machines on the physical machine if you turn on Hyper-V. You can have Hyper-V containers running on the physical machine alongside the virtual machines. You can have Windows Server containers running alongside the Hyper-V containers, running alongside the virtual machines, all running on the same physical machine. And that's perfectly valid. Of course, the first two require Hyper-V to be present. The Hyper-V containers requires the virtualization bits to be present, the innovation that we have done with Hyper-V. And virtual machines require Hyper-V bits as well. Sorry, I'm stepping back, trying to get the clicker working. You could have virtual machines deployed on your physical box, and you can deploy Hyper-V container inside a virtual machine. Or you could have Windows Server containers deployed inside virtual machines. Is it spinning your head a bit? Maybe. Again, Hyper-V containers require that Hyper-V be present inside the virtual machine.
I think it's just important to note the physical machine. Notice that we didn't say Hyper-V is required there. If you want to run VMware and run your virtual machine, your Windows Server virtual machine, and then put Hyper-V containers inside of that, fine. You want to run Xen, KVM. All that matters is that the hypervisor underneath the Hyper-V container is Hyper-V.
Clear as mud. Thank you. So yes, so we need Hyper-V running to launch Hyper-V containers. Hyper-V requires virtualization extensions to be present, both on the physical or the virtual. That implies that if you're running Hyper-V containers in a virtual machine, then the underlying virtualization platform needs to support something called nesting. Nested virtualization that's exposed into the virtual machine. So effectively, what have we done? We have provided a bunch of tools and software that enables a lot of choice. The choice that you have is you pick the cloud, whether it's your public cloud or your private cloud or the hybrid cloud. Now what you see here is all Microsoft, but to be honest, when we talk about containers and the Microsoft Windows Server containers or Hyper-V containers, it didn't really matter. You could have it on a VMware or an AWS cloud. Anywhere that Windows Server can run, you can have our containers running. The container technologies, the choice that you have Linux containers, you have Windows Server containers, both Hyper-V and Windows Server containers itself. You have a choice of the management tools that you want to use. I'm just summarizing what you have, but making sure that you understand the different pivot points. You also have a choice of the development environments, and this is where we start talking about what is your favorite tools that you use to manage and deploy it. There was an earlier demo where you could have a tightly integrated environment with Visual Studio, where you can just publish and run the applications. The demo you saw was with Docker and Linux containers. The same thing applies to Windows containers as well. As long as we maintain the parity of the API, the Docker API, all the tools you're used to that take advantage of the Docker API will continue to work with Windows containers as well. Another way to look at the whole thing again is what are the choices that you have in terms of containers and other runtimes. One of the questions I got asked at the Docker booth was, is containers competing with Service Fabric? Are they the same? Are they different? And the answer really is they are all different layers. As software developers, you get to choose whether you want to deal with containers natively or you want to deal with Service Fabric and build your applications at the Service Fabric level. And if you choose to use Service Fabric as the platform on which you want to build your applications, I would say forget about containers. Service Fabric will take care of how to run it and where to run it and what is the right runtime environment it will choose. Now, the ops guy might have opinions about what level of isolation is needed, and they can tweak it. But as developers, you should not worry about anything. You just worry about your runtime environment, you use the right APIs, and then Service Fabric will create the right orchestration model to ensure that you have a scaled out application with state-separated and state-consistent application that gets run somewhere. But you might also choose to say, nope, I want to have my applications run natively as containers. I want to have the control of how the containers are created, how they scale out, because I love to do my own orchestration. Absolutely. In fact, you might choose to use some other orchestration engine that's built over Docker as an ecosystem. You might have Docker provides their own. There are other with Mesos and Kubernetes that you might want to use. As long as it uses the right supported APIs, you can choose that. Okay. Someone's having a party. You can choose to deploy your applications, and this is where it's very important for you to understand. It's not all about containers. It's completely okay to have your workload be run natively on virtual machines. Virtual machines are not going anywhere. So it depends on your use case to figure out what is the right tool that I have to use. It's quite possible that physical machines are the right environment for you. Or maybe it's Linux virtual machines with no containers. I don't care about containers. That's perfectly fine. The choice is still with you. And finally, you have a plethora of the development platforms, the runtimes, the languages. We are striving to ensure that all of those continue to work in a Microsoft environment. A lot of these languages, a lot of these runtimes work natively on Windows Server. You heard Jeffrey and Andrew talk about how we are ensuring that most of these platforms and runtimes continue to work on Nano Server. All of those would continue to work in a Windows Server container and your Hyper-V container. So the choice of your runtime should not dictate what your end result is going to be. So essentially what you're saying and what we are doing is trying to help you decouple your final destination of where the application is going to run and make it a very late binding conversation, a late binding decision. When you're building your application, you might choose to have written the application where it runs on your private cloud. That's okay. Later, the policy might change where it says, I want to move that up to the public cloud with Azure because I want to take advantage of the scale. My business is growing. Or maybe I acquired a new company. I have a new branch office. I need to spread it out. Perfectly fine. And that is the flexibility that you keep getting when you start decoupling your runtime, your development platform, and your actual deployment options. So, summarizing, I hope you know enough about containers at this point that makes you dangerous. I bet you have tons of questions, and Taylor and I are here to ask the questions. Taylor also has a few demos that we want to go through. But I just quickly want to make sure that you understand when to use containers, when not to use containers, how it is applicable, and essentially what Microsoft is doing. So over to you, Taylor.
Yeah, so before we kick that over, this will be in the deck as well. If you want to follow up what's next, our documentation site, our MSD Insight, is going to go live on Monday. Right now, that's going to have like, what are containers? More or less what this session is, those kind of questions. But as soon as we have more things available, that's where it's going to go. You can always follow me on Twitter, and I will be tweeting things out as well. But with that, let's kick over to some more demos. So I literally just wrote some of these, like playing around while Matthew was talking, so we'll see how well they work. First thing I was going to show people, I've gotten this question a lot, where's the code going for Docker? There you go, Microsoft/Docker. This was the last pull request that was merged in the master branch, but all the real stuff, if you really want to see the nitty-gritty, is in this branch, JJH Argonne. Argonne was the code name for Windows Server containers. And so that's where all the code's going. That's where all of our work on the Docker engine's going. So feel free to go dig around and look around. Now, it's not going to do much without a build of Windows that supports the container primitives. That's coming this summer. So everybody will have that build. That's where the build's going to come out of. That's where all the merges are going back into Docker. I think we submitted something like 30 pull requests last week. So the code's going back to them pretty rapidly. So with that, let's go over. So something I was going to show is actually how we create a container image without using a Docker file. So there's a step where you can actually say a commit. And what commit does is it makes an image. So let's make a new image. So what we're going to do is we're going to do a Docker run again. We're not going to specify RM because we actually want to keep the state. We actually want this container to stick around afterward so that we can take its state with us. And we'll say Windows Server Core, and we'll do a command prompt. So again, we're just starting a new container from Server Core, and then we're going to install .NET. And I tried to install IIS, but it actually turns out there's a bug right now, and IIS doesn't work, and it blows up gloriously, so we'll skip that, and we'll do .NET. So we're running the same command we normally would. We're just running dism. So there we go. We've installed .NET. So now what we would do is exit. So we've exited the container, and when we get back to Docker here in a second, we're going to see the Docker, if we do a Docker PS, container's gone. If we do a Docker PS -a, we can see all the containers that are run. So the one we want is this guy, Hungry Point Care. And so we're going to say Docker commit of that container image. And that will make a new image. So if we do a Docker images now, could have given it a friendly name, but I didn't, none, then that's the image ID. So that's how I'd actually create an image not using a Docker file. So I could have done a bunch of stuff. I could do, I could have run done multiple installs. I could have done all sorts of stuff. But I can also now say Docker run -it that guy cmd. So now if I was building another layer of an application, if I was building a new .NET 4 application, or if I had an existing .NET 4 application, I could now then install that into this image, and they have a dependency on each other. But I've separated the state. So if I have another .NET 4 application tomorrow, I don't actually have to go install .NET again. I can just use the same image. And the more commonality you have, the more memory we're going to share. Because what we're going to do is when we actually start up this container, we go, these are all the files it needs. We'll throw those into the cache. Another container starts up and it uses some of the same files. We don't load them into memory again. They're already there. We just reference it. Right? So the more commonality you have, the better the density is going to be and the easier it is to manage. So what else can I do? Can I run PowerShell in the container? As of last week, we can. So we actually have PowerShell working. So I can do get-item. I can do all the normal PowerShell things inside of a container. Of course, we're going to have PowerShell remoting working. So you'll actually be able to PowerShell remote connect into a container. Why would you want to do that? Well, maybe you're actually trying to troubleshoot something or do some debugging of an issue. You can get into a container and use PowerShell just fine. Let's see, what else? I can do task list, right? These are all the tasks. This is actually a cool little fact. You see 14 over here. That's actually part of how we're doing the virtualization. We're giving each container instance its own session. So if I started up another container, new version of Docker here, IT, Windows, Server, Core. If I start up this new container and run task list, we'll see it actually has a different set of session IDs and a different set of process IDs. So task list, there we go. So we see the system task 4 is actually the same, right? Because that's shared, that's the kernel basically. But then CRSSS and SMS, different. And the session's different. Each container has its own via the session. But we also virtualize it. So when apps actually ask for session 0, guess what? That's what they get. They just don't realize that they're actually being virtualized. Right. Pretty cool stuff. So how are we doing on time? We got a couple minutes left. I do want to leave a minute or two, a few minutes for questions. Actually, anything else you guys want to see? Got a container up? How does it deal with domains? That's a good question. So right now we don't have domain support, and we probably won't in our V1. And part of the challenge is that containers and domains are kind of different challenge sets. Right? If you join a container to the domain and then you turn it off and give it to someone else, and now you make 10 copies of it, Active Directory doesn't really deal well with having 10 machines with the exact same ID started up at the same time. Different domain than the host? They actually are not, they're not on a domain at all. So they just don't show up as a domain account. And in fact, if we do right now a set computer, we'll see that it's just got the auto-assign name. Now we are going to virtualize the host name. So I would be able to, as part of running my container, say, your name on the network is going to be my cool website, and we'll redirect that as a host name. But as an Active Directory object, it's not going to have an identity today. We are thinking about how that will work in the future, but for today, that's kind of what we think we'll be. Licensing, the big licensing question. We are not making any announcements regarding licensing at this point in time. Those will come in the near future. So how do you handle external dependencies on the network like a SQL server? So there's a couple answers to this question. You could actually do it as part of like a Docker Compose or a Docker a collection of containers, where I could actually say the SQL server is one container, and it's got its database files maybe externally stored, and I've got my web server as another container, and I can actually plug those two together through networking. So I can say, when you start, go look for your data over here. That would be one model. I think a more common model is going to be that you actually run your SQL server in a virtual machine because it's the right tool for that job still, or as maybe Azure AD or Azure Database, and you just point your container at that resource. So it's got a full network identity, so I can run ipconfig in here. I can give it an IP address. I can put it on a different network. I can use network virtualization, all of those kind of things. We'll still work with it, absolutely. What about viruses and malware? So we do have, as Jeffrey talked about before, we do have Defender running in every instance of Windows, including in containers. We will have malware detection running in containers. Now the cool thing is, if you got a virus or something, it's just like the cattle analogy earlier. Well, start up the grill, throw it away, start another container, or patch the container image, and then when I roll those next set of containers out, I'm going to have that instance addressed.
But that's part of the immutability aspect. Even if you get something in there, the minute you kill it, it's gone. So the next instance you start won't have that. Sorry, they were.
Ah, yes.
Yes.
So we have full resource controls, CPU, memory, network, disk throughput, disk size. Those will all be, those are at least in the V1. We may have some more, and we probably will add more over time.
Access to custom hardware and a PCI slot. So if an application needs access to a PCI slot.
So this is kind of an interesting question. It's a little nuanced. So in Windows Server containers, because there's a shared kernel, applications inside will generally see the actual hardware underlying. But that's really not the right model. And certainly in Hyper-V containers, they're just going to see the virtualized set of hardware that normally would be there. Now the challenge with using physical hardware is that I kind of break that run anywhere model. Now I'm in a run anywhere where this hardware happens to be present and is configured the right way. So I kind of think over time we're going to see a little bit of both, but generally we would say avoid kernel dependencies in hardware.
This Windows Server Core is the first line of Windows container, right? Will you also support running the Azure packages in that kind of environment?
Will we support running the Azure Pack? So the first thing is we're going to have both Server Core and Nano Server as container OS images. Those will both be available. Generally, I would say the Azure Pack would be running on the kind of the physical machine or the container host, the virtual machine that's the container host, used to manage containers. It probably will not be plumbed into the Azure Pack and tomorrow, but over time, I think we'll do that. The Azure services are very much virtual machine specific today, and we're going to have to teach them about containers.
Running Linux images, is that only in a Hyper-V container?
Linux images actually are not even a Hyper-V container. Linux images need a Linux virtual machine or a Linux physical machine. Now the Docker tools will use both, but Windows containers and Hyper-V containers are for Windows container images.
New containers, how big is the memory consumption and storage?
How much memory are they using? So we still have a lot of optimizations that we're doing. Right now, the one that I started, I think the last time I checked, it was about 120 meg. We also don't have a lot of our sharing turned on. So more is going to come around that, but we expect that the density is going to be pretty good.
I have a Hyper-V, if I'm running a Hyper-V container, am I actually in a VM? Am I actually running a Type 2 virtual machine inside?
Both are type 1. They're both type 1. The same Hyper-V.
So, let's say I have a node, and on top of that I have Hyper-V, I have a bunch of VMs. Inside one of those VMs, if I run a Hyper-V container, I'm actually running Type 1, not a Type 1.
Hyper-V on Hyper-V.
Yep.
So that's an announcement.
You didn't hear it.
Yeah, yes.
Is there any difference between the images of a Hyper-V container versus
A Windows Server container? No. They are exactly the same.
So the easiest way to think about a Hyper-V container for me, think about a Windows Server container that's wrapped in a Hyper-V partition. And literally that's more or less what we've done. We've taken a Windows Server container, the exact same runtime, and we're wrapping it in a Hyper-V partition. So
Would the
they will,
base-
yeah, so they will likely be distributed out of a Microsoft place, but we are going to make sure that they're plumbed through Docker Hub. So if you're using Docker Hub and you say pull Windows Server Core, whatever we end up calling it, that'll be a seamless thing, but it'll actually probably come from a Microsoft site.
Talk a little bit more about patching.
Yeah.
Patching somebody giving you one of these things and then they get patching.
So we're still working through some of our
Question.
patching stories. What?
Repeat the question.
Oh yeah, what's the story with patching? There's going to be certain points in time when you have to rebuild, and that's actually where the Dockerfile model comes particularly important. So you actually see people checking in their Docker files to the Docker Hub so that they can get rebuilt automatically. And that is the ultimate address to a patching scenario. Because yeah, if you've got a base image that needs to be patched, and you don't have any way to build the instructions on top, then you're on an unpatched.
The story is very similar to what's happening in Linux as well.
I know it just turns patching from a really ops thing into a really DevOps.
Yeah.
Yes and no. It depends on how you have built your application. If the rebuild of the image is automated, like with the Docker build, then it can still remain an ops workflow where they are, as part of every Patch Tuesday or whenever the base image or the intermediate layers have to be updated, you just rebuild the whole image and redeploy it. So the developer doesn't really have to get involved unless an API is changing, in which case, yes, obviously the developer has to get involved.
Yeah.
So the question was, what's the patch level difference between the container host and the container base image? This is one of the unique differences between a Windows Server container and a Hyper-V container. For Windows Server container, they have to match because of the shared kernel. But if it's a Hyper-V container, the kernel is different, so you can actually have differences in terms of the Hyper-V container can be a different, well, patch level or even version level from your container host. I should let you guys go because we are right at the time, but we will hang around here, so if you have more questions, please do come by. And thank you very much for being an awesome audience.
Thank you.